So here's how the assembled support looks. This edge slides against the raised area of the ways to keep it lined up. I found this piece in the scrap bin, and it happens to be just about the right size and shape, and even has a convenient center hole. In its current configuration, it's a little bit too wide to fit between the ways, so I'm going to trim it down. In your own shop, if you had a project like this and you didn't have a mill, you could use the 4-jaw chuck and use an interrupted facing cut as I've demonstrated. But in the interest of getting the job done, I'm going to go ahead and mill it to size. To determine the size, I'm going to use this snap gauge, or actually more correctly it's called a telescoping gauge, because a snap gauge is actually a different type of measuring instrument. But these are sometimes called snap gauges because of the sound they make. So I'm reading about 40.5 across the inside of the casting there. This factory one's about 37. But I'd like to make it a little oversized initially, and then I can cut it down. But better to make it big and cut it down than to make it too small and be stuck. It's actually 42.25 currently. So I'm going to go ahead and take it down to 40. I'll take about 1 millimeter off of each side. The goal there is to keep the hole roughly centered. That should work okay. I found this 8 millimeter metric bolt, and I'm planning to use a lock washer and a nut just so that this will stay together as one assembly like the factory one does. And I'm just holding it in the chuck because that's a convenient way to hold it while I'm tightening it. Now I want to go ahead and drill a hole for the bolt to come up through this cross plate here. I want this edge to ride against this raised area here, so it'll slide more or less like that. So I want to center this hole between the two rails of the ways here. So I've got my metric scale with the end lined up against the raised area, and my goal here is to find the center of this spacing between the two parts of the ways, and that's the point at which we'll drill the hole. This is going to be an 8 millimeter hole, and I'll drill it in 2 stages, starting with a 6.5 millimeter. And of course I'm going to really start with a center drill, and it's a number 3 center drill. We'll come in with a 6.5 millimeter. And there's nothing special about that size, it's just an intermediate size. I'm going to use this countersink to just lightly chamfer the 2 holes to remove any burrs. I'll just run the spindle at slow speed, and I'm going to hand hold it. Just apply some upward pressure, and there you go. Quick and easy. Now with the bottom plate in place, we can slide it along. Use a wrench to lock it, so it's pretty sturdy. Now with everything lined up pretty much the way it will be in operation, I'm going to mark with a Sharpie pen where the top of the vertical plate lines up. I'm not too concerned about these marks right now, they're only approximate. They were just there to help me gauge things along the way, but it doesn't matter if they're aligned at the right angle at this point or not. We only have a limited area here where we can put these bolts. Take it over to the layout table and see if I can work out some reasonable spacing and positioning for those holes. I brought the workpiece over here to the surface plate just because it's easier to do this layout work, but I have 2 of these perforated 1, 2, 3 blocks just very loosely bolted together. They're just finger tight, but that gives me a solid surface to put my workpiece up against. And I took a measurement of these holes that I drew, and it turns out they're very close to 40 millimeters, so that's what I'm going to go with. And then we will position them vertically so that they are at the midpoint of the height of the thickness of the ring. I'll use the height gauge to get an accurate measurement of that distance there, that thickness, and it looks like 16.58, but you could measure that equally well or almost as well with digital calipers. You may recall that early in the video I mentioned that a lot of my projects don't conform to nice even round numbers, and this is a good example of that. So that thickness, just because of the process that I followed, ended up at 16.58. So half of that for the midpoint is 8.29, which is another squirrely number, but doesn't really matter. Now, if you're an engineer or a purist, you would probably want to make sure you have all those come out to nice round numbers, and ideally I would like to do that. But when you start with a piece of scrap material from the scrap bin, you don't always have that flexibility. But, if I wanted to put more time and thinking and planning into it at the outset, and in particular if I wanted to make an accurate dimension drawing of it using some software like DeltaCAD, or more recently I've been playing around with SketchUp, which is a three-dimensional tool, and I like it a lot. So I think I'll begin using SketchUp for a lot of my planning going forward. Before I start making my actual layout lines, I want to make sure this is clamped securely, and you may notice I have a little thin strip of wood here. This was just some scrap wood that I cut on the bandsaw for this purpose, just to protect the finish on the ring. I think the tricky part for this layout operation will be, once we've scribed the midline across here, we now want to mark two holes that are exactly 40 millimeters apart, but they need to be centered on this point here, and they also need to be perpendicular. The line through these two needs to be perpendicular to a vertical line here. So I have to give a little thought to how I'm going to do that. Laying out these two bolt hole points turned out to be a little more complicated than I expected, and I have this gut feeling that maybe I'm overlooking something obvious here, but the way I went about it was to clamp the ring onto a 1-2-3 block on the surface plate, and I just found this piece of scrap material that happened to have a whole 1/4-inch hole in the center, so it was just right. This is just a spacer, and I used that just so I didn't have to thread this on as many threads, because I had to play around with this for a while and I had to keep loosening and tightening this nut to get it right. The bottom of the ring is lined up with one edge of the 1-2-3 block, and then one side is, and I used this little Harbor Freight soft face hammer, so I tapped the sides to make sure that it was actually flush with the surface of the plate. So I tap it there and there to make sure that the edges of the ring are aligned with the edges of the 1-2-3 block. A few years ago I made this adapter for my height gauge so that it can hold a fine tip Sharpie pen in there, and I use this all the time for situations like this where I don't want to scribe a line. I merely want to mark a line on a surface, especially in the early stages of layout. If you aren't quite sure where you're going to end up, you don't want to go scribing a bunch of lines and then find that they're all in the wrong places. So I enjoy the mental exercise of trying to figure these things out, and that's all great. But I assume that many of you do not have a surface plate. Maybe you don't have a 1-2-3 block, and you probably don't have a height gauge. So if all you've got is a mini lathe, that's not really much help. So what do? Let's suppose you don't have a surface plate or a height gauge or any fancy measuring tools, and all you have is a metric rule similar to this one. I'm just going to mark a straight line right along the edge of the bore here. Okay, and now once we've got that, let's use our scale to find the approximate center. We will. Alright, now we'll take our rule again and lay it across this way, and we can use a line going all the way across there to get it approximately square. Okay, now we've got a center line. I'm going to line up the 40 mark with our center line just as a convenient reference, and then I'm going to come out 20 from there and then back this way 20 from there. So that gives us our 40 millimeter spacing between our holes. And now we'll top of the rule with our line and perpendicular line down there, and another one over on this side, and it looks pretty close. So now what we want to do is find the midpoint of the short segment. So we'll measure that, and it looks like it's about, we'll just call it 12. So we'll come out here and measure off 6. So out here where the screws are going to be, that will be the midpoint. And then we'll just take our rule again and square it up and draw a line there and a line there. And that gives us our 2 screw hole positions. So they're vertically centered within this region, and they're spaced 40 millimeters apart pretty accurately. So that's good enough to get the job done. If you started out just working on the vertical plate, I don't know how you would arrive at that distance, but now we can measure it, or we know it, so we can transfer it to the vertical plate. I've temporarily disassembled the vertical plate from the base plate just to make this layout work a little bit easier. And then these should be the positions of our bolt holes. So our 2 bolts should go through those cross points there. It's approximately matched. So this is probably good enough to do the job. These aren't real accurately positioned, so if I drilled them out, there's a good chance the holes wouldn't line up exactly and I'd have trouble. If I then were to drill and tap 2 holes here and try to run 4 millimeter screws through there, I would probably have alignment problems because these just aren't lined up accurately enough. What I wanted to check, and this sort of gives me an eyeball, is whether these holes are too close to the edge here vertically for strength. And I'm a little concerned about that. It would be better if they were a little farther down, but then we'd be getting too close to the bottom of the ring. So one possibility would be to move the 2 holes in farther. And this is the situation I was trying to avoid by having the arc-shaped piece here, that we could come up farther on the disc and have more meat to work with, so to speak. But since we don't, we have to think about whether we want to come in a little closer. So instead of spacing these 40, maybe we'll make them 30. Let's take a look at that. 15 on that side and 10, 15 on that side. And once again, we'll drop some verticals down. Now I'm going to draw some corresponding holes down here on this piece. So we'll go out to 15 and down to 15 here. And then our 2 holes will be there and there. Yeah, so I think I like that a little better. Now another advantage of this, when I'm out here, the midpoint, the height from here to here is only about maybe 12 and a half, maybe 13 millimeters there, we'll say. But as we come in here, it's about almost 19 millimeters, so we can drop these holes down farther. Now that I have my plan of attack worked out, I'm going to try to redo this, and just in the interest of this being a field expedient project, I'm going to try to do it using nothing more than this inexpensive rule and a scriber and some layout die. I can't see as well as I could when I was in my 20s, but there's still a possibility I can do this. So I put a little red layout die on the work. The thing about layout die is you want to be careful not to spill it down the side of the bottle, or you get it on your hands and anything else that it touches. I decided to scribe these lines off camera just because I needed to work very closely and use magnifying glasses to see what I was doing, and the camera would definitely have been in the way, but this is what I ended up with. So I've got my 2 lines here that are 30 millimeters apart, and I think they're pretty close. We'll find out. Well, I was thinking I could go ahead and put these on the mini mill and just use the DRO, but that wouldn't prove anything. Even if my layout was way off, they would still come out very close. Just to show that it can be done, or I hope I can still do it, that I can lay these out and I'll drill them with a hand drill just to see what results I get. I'm just going to use this inexpensive Harbor Freight drill, and I've got a number 2 center drill in here, and I'm using that to start the hole because it's stiff and won't flex. I'm not real happy with that first one. Let me try the second one. I'm going to use a little Tap Magic aluminum on here. This drill bit seems a little dull, or maybe just I don't have enough pressure on it. Well, this little exercise gives me a renewed appreciation for the tools that I have now. Next, I'll drill the 2 holes. I'm going to drill them through just because it's easier and it'll give me better chip clearance. I'm using a 3.5mm tap drill. This is a short drill because it came in a set with drills and taps. I'm going to clear the chips and put a little more cutting fluid in there. Okay, and I felt it break through into the sacrificial board there, and hopefully not into my countertop. Okay, there we go. Off camera I made this, we'll call it a field expedient tap guide, since we're into field expediency right now. But it's just drilled through with a hole just big enough for the tap to pass through, and I lay that on my work and use that to support the tap so it stays vertical. I got to get some cutting fluid under there. Back the tap out, break the chips. And of course the tap's going to run through the bottom there. I'm going to have to put some kind of spacer under here when the tap gets through. Alright, I can actually thread a 4mm screw in there, so that's a good sign. I'm back over at the lathe, and I first want to just use a handheld countersink to remove any burrs that would be extending above the surface there. Because these holes probably are not exactly 30mm apart, and they may not even be exactly in the same plane vertically, I'm going to see if I can use a transfer punch to mark the hole positions on this vertical plate, so that even if they're a little off by my measurement on the ring, they'll still match up with the vertical plate, which is what's most important here. First, I'm going to use my surface gauge on the ways, and just as a method to see if these holes are approximately horizontal. So I'm just using this probe to determine if they're about at the same height. Of course, I want to get them as close as I can, but if they're a little off, it'll be okay because of the method that we're about to use. Now I'm going to bring the sliding plate up here, and I have to be careful not to move the ring while I'm doing this. And then I'll try to get some C-clamps on here. First one here. And I'm turning it gently so I don't move the ring while I'm doing it. And now we'll get one on the back side. Make sure they're tight. Now I'm going to loosen up the chuck, and I can slide this right off of there. And then we'll just run a transfer punch through these 2 holes. In case you're not familiar with them, this is a set of transfer punches, and this set is metric, but they're also available in inches, and they typically come in sets like this that are matched to similar sets of drill sizes. So this set runs from 1mm up to 13mm in increments of a ½ millimeter. And you can get these from Harbor Freight or Little Machine Shop or other places. So they're used like a punch, and when you hit the back end with a hammer, it will leave a little indentation in the workpiece that you want to mark. I've got this assembly positioned on some 1, 2, 3 blocks to provide a solid surface so that the punch will take effect. Now I need to find the correct size punch, and I want to use the largest punch that will fit through the existing holes. Now these are 4mm holes, or they're tapped 4mm. This is a 4mm punch, but of course the inner diameter of a 4mm tapped hole is less than 4mm, so it won't fit. So let's try the 3.5. Still too big. And go down to 3. And it looks like 3 will work. So this 3mm punch will fit, but it's kind of loose and wobbly, and that's because these are sized for drilled holes, not for tapped holes. But I found that a 1/8 inch diameter punch from my SAE size set fits closer. It's a better fit, so I'm going to use that because it will be more accurately centered. Just going to take a ball peen hammer and gently tap it here, and then in the other hole. And with any luck, that will give us what we need. Let's take a look. So here are two little punch marks. You can see there's a Sharpie line here, which is parallel with this edge. So in fact, the punch marks aren't quite parallel, but that's exactly what I anticipated, and that's the reason I used this method. So it's sort of an ugly arrangement from an aesthetic standpoint, but it will get the job done. And this is, after all, a field expedient steady rest, so we're allowed to have a little sloppiness. If you don't have a transfer punch set, another method I've used in the past that works pretty well is take a pair of soft 4mm bolts. You don't want to use hardened black steel ones, but just some soft ones like this, and put them in the mini lathe, cut off the heads, and then turn it down to a point. Choose the size so that it's just a little bit longer than the thickness of your plate, and then screw them in until just the point is sticking out here, and then you'll have 2 points that match up the centers of the holes, and you want those just protruding a little bit from the face. Then you can take your vertical plate here and just give it a whack with a soft head hammer. That will make an imprint on the face of the plate, a lot like the transfer punch did. I've got the vertical plate, and I'm going to try to drill these through holes by hand, just using a hand drill. And I've got the two little punch marks that I made with the transfer punch, but I want to make them a little bit deeper with this regular punch. This time, instead of using a number 2 center drill, I'm going to try using the smaller number 1 center drill. You remember last time I didn't get a very good start on my hole, and that caused the hole to be a little out of position. A little Tap Magic on there, Tap Magic aluminum. That went better than last time. These are going to be 4mm through holes, and but I think I'm going to make a pass first using a smaller diameter drill, just to take a little bit lighter load on the drill. I'm going to use a little drill guide. This is drilled, I think, 0.128, just a little bit bigger than the drill that I'm going to use. So I want to get my Tap Magic aluminum down on there. Then we'll put this over the drill bit for alignment. Get the drill down in our starter hole there. While I've got the starter drill in the chuck, I'll go ahead and drill the second hole. I'm so used to using the mini mill to do this type of drilling operation. It's been a long time since I've done it by hand. I'm finding it to be a little harder than I remembered. Okay, so we've got our 2 starter holes now. Now we'll go ahead and drill them out 4mm. Still going to go ahead and use this larger drill guide here just to help keep things on track. Drill bit's grabbing. Yet another advantage of doing this on the mill. Yeah, these larger holes would have been better if I had held that in a vise to do the drilling. It actually grabbed the workpiece and pulled it free from my hold there, so that's not a safe situation. But like I said, you know, when you don't do this every day, you forget some of the basics. I'm just using a little countersink to clean the burrs off the holes. And then I'll blow it out with a little compressed air. I'm going to use M4 by 25 millimeter bolts. I want the thread to go pretty deep into the ring here, but without coming out the back side. I may later decide to counterbore these heads and sink them below the surface, and if I do that, then I'll go to a shorter, probably a 20 millimeter. I didn't run the tap all the way through these holes, so I don't have a completely formed thread at the back side, so I'm going to run that through again and clean up the back end of those threads. Well, this whole job reminds me a lot of how I started out many years ago, and it makes me appreciate the having the machines to do this more accurately and more easily now. But you know, sometimes you don't have that, and certainly when I started out I had very little to work with, so you got to do what you got to do. And this is what usually happens when you try to do these by hand, or at least when I try to do them by hand. The first screw went in fine, and it looks like everything's lined up properly, but the second screw is binding because the spacing between the two holes isn't exactly on center. So what I'm going to have to do is enlarge one or both of these through holes just to provide a little more clearance so that the screws will fit. So usually I start, you know, with the next larger drill size, and sometimes you have to go 2 or 3 drill sizes depending on how bad the situation is. I drilled both holes out to 4.4 millimeters. They were 4. And that looks like it was enough to get the job done, although they're still binding just a little bit. So 4.5 might be better, but this is okay. And I also remembered that I also realized I was assembling this with the lower plate sticking out this way, and it needs to go back this way. Let's take it over to the lathe and see if it fits. Alright, well, I've got it over here on the lathe, and seems to line up pretty well with the chuck. It's good to keep in mind that I only use the chuck as an alignment aid, you know, to get this whole thing set up. But in actual operation, the steady rest will be out here somewhere, or maybe even farther back, and the workpiece will be floating within the space and adjusted by screws. So the alignment is as good as it needs to be, and probably better than it needs to be, but obviously you want to make it as good as you can. So let's put the clamping screw in place and see if that all works together. Alright, well, looks promising. So I think we'll stop there for this video. In the next video I'll drill the holes for the adjustable bolts, and I'll do some sort of modification to the tips of the bolts so that they don't gouge out the workpiece.